Hi. Hello. Right. What shape is this? Circles. Today, we are going to do about properties of circles with Kumar. I'm not cooking, alright? But I've innovated and I was thinking of getting a compass to draw a circle, but I thought, why not? I use this. It's so easy to draw circles. And I said, hey, I think I want to sell this in schools. You know, you want to buy one? Right? Right size circle. Right, circles, everything. Remember circles? A very important shape. But I want to say if your body looks like a circle like me, oops, it looks like me. Oh no, that looks clumsy, right? But you see, the world, the earth is a circle. And I told you about bearings, we move in circles, all right? And so it's so vital that you know the properties of circles. And I want you to learn with meaning. Now, it's not difficult. If I have a circle, and if the circle, if I draw a line like this, is called a chord. C-O-R-D, a chord. And this chord divides the circle into two, what do you call that? Segment. This is called the minor segment. Alright, let me write it. Minor segment. And that's the, what is the word with minor opposite? Major segment. So please take note. Minor segment, and that's the major segment. Okay, so major segment. Now it's quite easy to remember it, right? Minor, major. So this is the major segment. Major. Now what worries me is that some students get, let me write this properly, major segment, minor segment. What worries me is some of you get confused between a sector and a segment. A sector means if I have a circle and I draw a part of it, and this is called a sector, a small part of it, all right? It's called a minor sector. So a minor sector is formed by the radius. This is the radius, all right? And the other region here, what do you call it? You call it the major sector. Minor, major. All right, so my dear vocabulary, sector and segment are two different aspects. Now when we look at the chord, now when I draw the chord, and if the chord passes by here, you call it a chord. When it passes by the center of a circle, you call this a diameter. And a diameter is made of two radius. Put together, you get a diameter. The diameter can also run across here. As long as it's passing through the center circle, you call this the diameter. But if it does not pass through the center circle, you call this a chord. A chord. It goes this way, a chord. Take note of that. And when the chord touches the circle, all right, at one point, this chord is called a tangent. A tangent is just a line kissing a curve. When I say kissing, don't get wrong ideas. Kissing means point of contact. All right, manage your raging hormones. All right, so it's touching one point. We call that a tangent. All right, so got the meaning of tangent? Tangent, touching at one point. This is called a chord, and that's called a diameter. Now, get these vocab right. Now, with a sector, all right, you look at a sector, you look at a segment, you look at chords, tangents, diameters. So I hope that definition is clear. This is a circle. A circle. What is the length of the circle from this end going round to come here? What is it? Let me get this, all right? Put this here. I got this lovely circle. Maybe in your school, for your school books, you may want to look for things like that. And then you can help to draw your circles easily. Some water covers, bottle covers. See whether you got the right one. And then you can draw it without using compass. All right? Be innovative, my dear. Now that length around the circle, that length, if I put a string around it and I bend it and I follow it up, and then I straighten the string and it becomes, I want to measure the length. All right? So when I put that, and this length of it, we call it circumference. Circumference, we write it in short. Circumference means the length of the circle, and the circumference is equal to 2 pi r. 2 pi r. And the area of this whole circle is pi r squared. So the area of a circle, equals to pi r squared. Now if I have a minor sector like here, and I said, hey, your angle, your length is 7 cm. Your length here is 7 cm. You are 60 degrees. Oh, 60 degrees. What fraction is it of a circle? What is the angle of a whole circle? It is 360 degrees. So this circle, this sector is actually equal to, if I put this area, you know, it's 1/6. You know how I get 1/6? The area of this sector is 1/6 of pi r squared. Because it's 60 degrees out of 360. 360, you cancel it, you get 1/6. Alright, so it's 1/6 of a whole circle. Similarly, what is this length here? The length here is going to be what? L is going to be 1/6 of the length of the whole circle. And what's the length of the whole circle? 2 pi r. When you go to my sector, the next chapter that I'm going to go on circular measure, you will learn a lot more of it about radians, circular measure, how to find out the area of that sector, funny shaped segments. You may be, at first, if you don't know, you will say, yucks. But when you know, maths is so easy, alright? So now today, having got this lingo right, I'm now going to barge you into, we're going to go into the properties of a circle. Are you ready? It's not very difficult. I think basically about 6 properties, getting them at fingertips, 6. All right, let's look at the first property. Now, if I have a diameter running across, I'm sorry, my center didn't look so right. And if I have a triangle coming up from it, this is called angle in a semicircle. As long as I have a diameter, this is called angle in a semicircle. So the property here I would like to mention, angle in a semicircle is equal to how much? Pi over 2. Pi is 180 divided by 2. That would be in radian. But if it's in degree, it is 90 degrees. Or you can put as pi over 2 radian. Got it? So angle in a semicircle is always equal to 180 divided by 2, 90 degrees. Alright, let me show you another one. If I have a circle, an angle like this is also an angle in a semicircle. This is also 90 degrees. If I have another angle here, I said, hey, this is a semicircle, and this angle how much? 90 degrees. Now, if I have another one here, I say, ooh, I want a small chord, and I draw a big line there. Look at it. You know something? You draw it and you find out. You'll be shocked when you use your protractor and you see the angle, hey, 90 degrees. The diameter will always be the hypotenuse. Alright, the longest side of the triangle, because whatever faces the 90 degrees will be the hypotenuse. Right, so that's your first property that you learned. First, angle in a semicircle, half circle, is always 90 degrees. And remember, it must touch the circle. Got it? Good. Second property, if I have, alright, a chord and I draw a triangle here, alright, and I draw another triangle here, alright, but draw. These two angles will be equal. Why is that so? Because they're looking at the same chord. Alright, A1 is equal to A2. Or the property that we use here, you're looking at the same chord. So we call it angles in the same segment. In the same segment. Now we remember we learned about segment. Segment, there's a major segment and a minor segment. So when we have a chord, we divided it into major and minor. And this angle and these two angles are equal because they're facing the same chord. Who are you looking at? I'm looking at AB. Oh, A1's looking at AB. Who's A2 looking at? I'm looking at AB also. That's how you recognize. Are you clear? Next, if I look at this angle, I look at here B1 and I look at here B2. B1 and B2. If I draw, my dear, dung dung, dung dung, I look at this B1, you're looking at this. Alright, you're looking at this line. B1 is looking here. And if you look at B2, your B2, you're also looking there. The same chord. I call it CD. So B1 is looking at CD, B2 is looking at CD. We call them angles in the same segment. Let me write it down. A1 equals to A2. You found your B1 equals to B2. Now, if I have another angle, dung dung, you see that? And you look at this. You look at like a bow tie. A bow tie. The corners of it. You're looking here. So this angle C1 is equal to C2 because C2 is looking at this chord CB and C1 is looking at CB. Just get the triangle out. Look at what you're looking at. Who are you looking at? Now, so that's why C1 equals to C2. Now, if I look at this, I call this line D1 and I call this D2. D2. D1 is equal to D2. What's the reason? Alright, C1 equals to C2, D1 equals to D2, because look at D. D is looking at who? AD. D1 looking at AD. D2 looking at AD. They all are a triangle. Look at that. So angles in the same segment. That's the second property that you have learned. Alright? We will reinforce it. Don't worry. You will get it so familiar. Now, once you've got that, the first one, angles in a semicircle. Recognizing a semicircle. Second one, angles in the same segment. Now, let's get back to that. Now, you look at this. This angle 90 degrees is looking at this line. Right? Look at the 3 points of a triangle. And do you see these two being equal also? Because they're looking at the same chord. Although we say they're angles in a semicircle, we can also say what? Angles in the same segment. You got it. Angles in the same. You're looking here. Yep. I'm looking there. Yep. We two are the same. Now, what are you looking at? Your books? You're looking at me. Look at the board. Circle properties. Excellent. Let's carry on looking. Move on. So we've got a second property. Right. Now the third property. Now if you have a circle, alright, and I think the center will be here better. And if I have a four-sided figure, we call this a cyclic court. What do you call it? A cyclic court. So in a cyclic court, what can you say? In a cyclic court, the properties of a cyclic court. Alright? You know, when you have court means a quadrilateral and it's inside the circle, you call it cyclic court. The opposite angles make up 180 degrees. The opposite angles give you 180. So if this is A, this is B. A plus B is equal to 180 degrees. Opposite angles of cyclic chord. CQ is what? Cyclic chord. Alright? So the opposite angles give you cyclic chord. But I want to tell you, sometimes, you know what happens? My students, sometimes I realize that they got a mix. They fail to see who's opposite. And that's why I want to make sure that all of you know, and I've made sure my students also know, opposite is here, not there, not there. Two different arms. This A is made of these two arms. And what is B made up of? Two different arms of the cyclic chord. Alright, say A plus B is 180. If A is equal to, say, 70 degrees, what will B be? 180, take away 70 is 110. If C is equal to 95 degrees, where C equals to D. And what is D equals to? 180 minus 95. You get 85. Yes. What do you call it? Cyclic chord. Now you look at that. Let me bring you back to this sum. You just look at any cyclic chord property. I look at this now. Ding ding. Ding ding. Four-sided. Ding ding. Do you see the cyclic chord? Do you see the opposite angles? 90, 90. 180. Alright? And if I were to draw another cyclic chord here, look at it here. 1. And look at it here. Do you see that? 90, 90. 180. And these two will also be 180 when you add them up. So these are properties that you got to know. Angle at center equals to twice. Alright? The angles of the cyclic chord, opposite angles, is equals to 180. I'm so anxious to teach you the next one. That's why I'm saying it before I could even. That's the center of the circle. And I want you to train your eyes to look it right.